Good afternoon, all. My name is Arun Sharma. So, today we will start the next chapter of Optics Grade 12, that is a refraction of light. So, in the previous video, we will discuss about the reflection of light, and we solve some numerical, and we solve some tricks, shortcut tricks on plane mirror, and some numerical on your NCRT and your NEET or JEE exam. So today we will start the refraction of light. Refraction of light. This is the second chapter in the array optics. So, first of all, what is an reflection? Reflection mean the bending of light in a same medium is called a reflection of light. So, we studied about a refraction. What is an refraction? Refraction is the phenomena in which the path of light as go from one medium to another medium, like the light travel from air to glass, air to water. That is called refraction of light. So just we understand, suppose it's a glass slab, and this is your a medium, or we can say that air medium or rare medium. This is your glass medium, denser medium, or B medium. Yeah, you can write here first medium or second medium. Light travel from air medium. This is your incident ray, and this is your refracted ray, and this is your normal. And this angle is I, incident angle, and this angle is R, a refracted angle. R mean a refracted angle. So you understand the one concept here. If incident ray travel from air medium to glass medium, this refracted ray move towards the normal. Why? Because the speed of light in air is greater than that of speed of light in a glass. So same case you can apply here. If light travel from glass medium to air medium, suppose this is your incident ray, and this is your refracted ray. It means the refracted ray move away from the normal. Same reason, because the speed of light in glass is less than that of speed of light in air. So this is the concept behind it. A ray of light traveling along the path is frequently it can move along the path. So we can say that the ray of light is traveling from air to denser medium or denser to air medium, and this phenomena is called refraction of light. So again we can discuss about law of reflection. So law of reflections, the incident ray, normal, and reflecting surface of the point of incidence and refracted ray all lie in a same plane. Same concept is applied here, and it is the ratio of sine of angle of incidence to the sine of angle of refraction. Mean we write here, suppose it's a medium, this is your B medium. A mu B, it is the ratio of sine of angle of incidence to the sine of angle of refraction. A mu B is equal to sine I upon sine R. This is also called Snell's law. This is also called a Snell's law. So here the value of a refractive index, mu is the refractive index of the material from B with respect to A depend upon. Mean this can be depend upon the nature of pair of media A and B. What is the nature? The wavelength of light and refractive index of the medium is greater in the violet light, and than that of red light. The wavelength of red color is greater than that of wavelength of your violet color. So in the previous video we can understand the concept. There are seven light is the electromagnetic spectrum, so seven spectrum are there. So like your x-ray, gamma ray, uv ray, big your infrared ray, microwave, radio wave. So the wavelength of radio wave is maximum, but you can do not see all the ray, just you can see the bigure, mean the visible region. So the wavelength of visible region is 4000 angstrom to 8000 angstrom, and the exact value is 3800 to 7600 angstrom. So we can discuss this concept in the previous video. So here we know about a refractive index. Refractive index is denoted by mu. It is the ratio of velocity of light in vacuum or air to the ratio of velocity of light in a medium. It means mu is equal to C upon V. C is equal to 3 into 10 raised to power 8 meter per second. The refractive index, there are so many value. You know the refractive index of like diamond, like your kerosene oil, water, etc. So there is one more concept. First of all, we will discuss about the your subjective portion. After that, we solve your numerical portion or JE or NEET question. So after that, after that, we will study about principle of reversibility of light. I mean how to reverse the light. So the principle of reversibility of light mean if light after suffering any number of refraction or refractions and finally the path is reversed, it travel back along the same path in the opposite direction is called the principle of reversibility of light. Principle of reversibility ability of light. Principle of reversibility of light. Just you understand what is an principle of reversibility of light. So how to understand this concept? This concept can be understood with the help of a glass slab. It's a glass slab. This is your incident ray. Strike on this. This is your A medium, and this is your normal. This angle is I. This is your B medium. Suppose after the glass slab, we can place a plane mirror. So if a refractive, this angle is R. If a refractive ray strike on a plane mirror, now it can retrace their path in the opposite direction. This is the principle of reversibility of light. So according to Snell's law, A mu B is equal to sine I upon sine R. Light travel from air to glass medium. This is the first case. Means this is your equation number 1. After that, the light strike on a plane mirror, it retrace their path. Mean the light travel from B medium to A medium. B mu A is equal to sine R divided by sine I. This is your equation number 2. Now multiply equation 1 and 2 we get. So A mu B multiplied by B mu A is equal to sine I sine R multiplied by sine R divided by sine I. It means A mu B into B mu A is equal to 1. A mu B is equal to 1 upon B mu A. This is the relation of principle of reversibility of light in a medium. So after that, we will discuss numerical on each concept. First of all, we will solve all the subjective portion. So after that, what is an lateral shift? Lateral shift. So how to find out the lateral shift? So first of all, if you find the lateral shift, the perpendicular distance between the incident ray and emergent ray when light is incident on the parallel side of the reflecting surface is called your lateral shift. So first of all, you will draw the diagram. One student can ask me in the last video, sir, can you solve simple microscope and compound microscope? This is the fourth chapter, but today we revise these two concepts again: simple microscope and compound microscope. So first of all, we will discuss the lateral shift. Lateral shift, that is denoted by D, small d, lateral shift. So this is your glass slab. This is your glass slab, and incident ray strike on a glass slab on this surface mean a medium. Now it bent. So again the concept is applied here. Incident ray traveling from air to glass, the refracted ray move towards the normal, and this is your emergent ray. Incident ray and emergent ray are parallel to each other. This is again a normal. This angle is I, incident angle. Understand the concept? And this angle is R, a refracted angle. Refracted angle. And this angle is again R in a same medium, and this angle is equal to emergent angle is equal to incident angle. You perform the activity in the grade 10 class. So after that, a parallel ray. So this angle is I minus R. This angle is I minus R. Now we draw a perpendicular from the refracted or emergent ray. Draw the normal. So this is called a D. D mean lateral shift. So you can mention the name N, N dash here. This perpendicular M or M dash. You can number anything else. So this is your A point. A. This point is Q, and yeah, O. This point is Q, and this point is B. This point is K. So the thickness T of the glass slab. So how to solve this? This can be solved by a particular method, means the angle I. Just increase the thickness of the glass slab. You can increase the thickness of the glass slab, increase the value of angle of incidence, and increase the refractive index of the glass slab. So the formula is, just you understand, D is equal to T upon cos R into sine I minus R. From the CBSE, this portion is deleted. That's why for JE or NEET, you can just remember the formula. D is equal to T upon cos R into sine I minus R. This is the main formula for the year lateral shift. After that, we will study about a refraction of a convex spherical surface. Just to understand, refraction, this is the most important concept. 3 to 4 questions are there. Refraction at convex spherical surface. It's a convex spherical surface and it's a concave spherical surface. All the resultant are same. So first of all, the question is refraction at convex, refraction, refraction at convex spherical surface. So the first part is, there are 5 to 6 parts. The first part is, just you understand, when uh, object lie in a rare medium and the image is real. When object lie in a rare medium and image is a real. So a real image. So first of all, you can draw the diagram. It's a convex spherical surface. This line is the principal axis. Here mu1 refractive index, mu2 the second refractive index, and object is placed on the principal axis O. Incident ray strike on a convex spherical surface and image is real. It means image is formed here, I, and this is your center of curvature. This point is A, this is your normal, very closest to the pole. All the distance can be calculated from the pole. So this angle is I, incident angle, and this angle, mean, this angle is R, a refracted angle. So you solve this question, you prove this question. So first of all, taking mean, first of all, you can solve when object lie in a real medium and image is real. So taking the triangle AOC, triangle AOC. Listen carefully. In here, angle alpha image beta gamma. So this is your object U, this is your image B, and this is your radius of curvature R. So first of all, AOC mean I angle is outside and alpha and gamma is in between. So I is equal to alpha plus gamma. Taking tangent, I is equal to tan alpha plus tan gamma. Tan alpha plus tan gamma. So first you solve tan alpha, triangle ANO, and for the angle gamma ANC. ANC. So tan alpha is equal to AN perpendicular upon NO base. N is very closest to P, so we can write at the place of N is P. It means AN upon PO. Similarly, ANC tan gamma is equal to AN perpendicular upon base AN upon NC. At the place of N we can write here PC. Now these two values put in this equation, I is equal to AN upon PO plus AN upon PC. This is your incident angle. So after that, you will solve R because we apply Snell's law. So taking triangle ACI, ACI gamma is equal to R plus beta. R is equal to gamma minus beta. We can write here R is equal to your gamma minus beta. Again taking the tangent, R is equal to tan gamma minus tan beta. So the taking the triangle of tan gamma, triangle ANC and ANI, ANC and ANI. Again, tan gamma is equal to perpendicular AN upon NC, so that we write PC. Tan beta is equal to AN. At the place of N, we write here PI. Again, put the value in this equation. R is equal to AN upon PC minus AN upon PI. Just you remember, we will find sin I and sin R. So mu is equal to mu2 by mu1 is equal to sin I upon sin R. Understand this thing? If the object lie in a denser medium, then you write here mu1 by mu2. Understand the concept? If the object lie in a denser medium, then you write here mu1 by mu2. Otherwise, if the object lie in rare medium, then you write mu2 by mu1. So here mu1I is equal to mu2R. In this case, you will put the value of I and R. So mu1, the value of I is here AN upon PO plus an upon pc is equal to mu2, and the value of r is here an upon pc minus an upon pr. So just I raise the this part. So you solve the question briefly. So a n remain cancel out. So we write here mu1 upon po plus mu1 upon pc is equal to mu2 via pc minus mu2 via pi. So rearrange mu1 upon pu, this is minus, so plus mu2 upon pi, here pc mu2 minus mu1 upon pc. So understand using sign convection. If you understand, here is the object, image is here, center of curvature is here. So object is a negative and image and radius of curvature is positive according to sign convection. Mu1 upon minus u plus mu2 upon plus b is equal to mu2 minus mu1 upon plus r. Now dividing both side by mu1 upon sorry multiply minus u plus mu2 upon mu1 divided by plus b is equal to mu2 by mu1 minus mu1 by mu1 divided by plus r. So you can see here mu2 by mu1 is equal to mu. It means this can be cancelled out. Minus 1 upon u plus mu upon b is equal to mu minus 1 upon r. This is your concept. So remember this formula, and if uh, in place of a real, if it is virtual, then again the resultant is same. अगर रियल की जगह वर्चुअल दिया है तब भी आपका रिजल्ट जो आएगा वो सेम आएगा. देयर इज नो चेंज. सो you know what is the right answer. So we solve one more case when object lie in a rare medium, image is a virtual. So you can see the result is same. So wait 1 minute. Here image is virtual. First we write here image is real. So image is virtual. So how to solve this? Image is virtual. So this is the convex spherical surface. You can see this line is the principal axis. This point is pole. Object is lie here O. Again you understand object lie in real medium, image is virtual. So incident ray strike on the surface, it's your mu1, mu2. So if incident ray strike on a convex spherical surface, then image is formed on the same side of the object I, and it's your center of curvature C. Clear? This is the center of curvature. So this angle is I and this angle is R. Here alpha, here beta, here gamma. This is your U, this is your B, this is your R, this point is A, this is the normal N. So again you solve the question and the resultant is same. So again taking the triangle AOC, AOC, it means I is equal to alpha plus gamma. Again taking the tangent, I is equal to tan alpha plus tan gamma. Again you taking the triangle of tan alpha and gamma. So triangle of alpha is ANO and ANC. Listen carefully. So tan alpha is equal to AN perpendicular upon base, that is equal to PU. N is very closest to the pole, that's why we write here P. Tan gamma is equal to AN upon PC. Now these two value put in this equation. I is equal to AN upon PO plus AN upon PC. So this is your incident angle I. So after that we solve R, a refracted angle. So how to solve R? R is equal to taking a triangle ACI. Triangle ACI. ACI. So R is equal to, that implies R is equal to gamma plus beta. Again taking the tangent, R is equal to tan gamma plus tan beta. Again the triangle of gamma ANC, ANC and ANI, ANI. So tan gamma is equal to AN upon PC, tan beta is equal to AN upon PI. At the place of N we write pole, because all the distance can be measured from the pole, that's why the N is very closest to P, that's why we write at the place of N is P. Now these two values put in this equation, R is equal to AN upon PC plus AN upon PI. Again same concept is applied. Again, same concept is applied. Mu is equal to mu2 by mu1 sine I divided by sine R. So it means mu1 I is equal to mu2 R. Mu1 I is equal to mu2 R. So mu1, the value of I, you can see here, AN upon PO plus AN upon PC, that is equal to mu2, and the value of R is AN upon PC, AN upon PI, AN upon PC plus AN upon PI. So mu1 upon PO plus mu1 upon Pc is equal to mu2 by Pc plus mu2 by Pi. Now rearrange this. Mu1 upon Pu, this is the positive, minus mu2 upon Pi is equal to Pc again same, mu2 minus mu1 upon Pc. Again you can apply sign convection. Pu is again opposite to the direction of incident ray. So it is taken as negative, minus u. Minus Pi is also opposite direction of incident ray. So minus mu2 upon minus b is equal to mu2 minus mu1, and r is the same direction of incident ray. So this is the concept. So just we erase some part. So you can see here uh, mu1 by mu1 divided by minus u minus minus plus mu2 by mu1 divided by plus b is equal to mu2 by mu1 minus mu1 by mu1 divided by plus r. It means mu2 by mu1 is equal to mu. So minus 1 upon u plus mu upon b is equal to mu minus 1 divided by r. So you can see the resultant is same in the both cases. So examiner maybe ask some question. They ask when the object lie in denser medium and image is real, yeah, maybe virtual. So you ready for it? If in place of rare, here is a denser, then you just a little bit change here. If here is denser, then you write mu1 by mu2, and all the concept is same, sin I upon sin R. So this is the concept of your uh, refraction of a convex spherical surface. Similar concept in the. So one more question for this. Yeah, we solve some numerical. So you know a real and apparent depth. So just we try lens maker formula. Lens maker formula. Listen carefully. It's a convex lens. This is your x, this is your y. This line is the principal axis. This is your optical center. This is the pole P1. This is second pole P2. So first of all, you understand what is the lens maker formula. Yeah, its assumption. The lens is thin. The lens is thin, and so the distance measured from pole of the two surface of the lens and can be taken as same as the distance measured from the optical center of the lens. The aperture of the lens is small. The aperture of this lens is small, and the object is the point object situated on the principal axis. You know, object is always placed on the principal axis, and the incident ray, refracted ray, made very small angle with the principal axis. They can make small angle with the principal axis. So just you understand, this is your object, this is your mu1, and here is mu2. incident ray strike on that surface. This is your incident ray and strike on that surface, and it just little bit bend, and it will form a image I, and the image of this portion, this is a concave, so this is a convex and this is a concave, and image of this convex lens is the object for the concave spherical surface. So image I1 is formed. Again, you understand. This is a convex and this is a concave. The image of convex spherical surface is the object for the concave spherical surface. So this is the object and this is the image. So after that, you can make a draw a normal from both the end. So this is your object, and we can draw the normal here. So this is your C1 center of curvature, C2 center of curvature. This angle is I1 incident angle. This angle is R1. This angle is I2. This angle is R2. This angle alpha. This angle beta. This angle beta 1. This angle gamma 1. This angle gamma 2. So all the distance are measured from optical center. So this is your objective U. This is your image B. This is your radius of curvature R1. This is your radius of curvature R2. So we will find first of all x P1 by mean convex spherical surface. So first of all you can take the object mu1 upon P1O. P1O. This is the object. Like your mirror formula. After that you can take image plus mu2 upon P1. What is the image? That is I1. That is I1. I1 is equal to first object, second image, and next one is your mu2 minus mu1 upon P1 C1 center of curvature. So P1 is equal to P2 is equal to C. All the distance are measured from optical center. Understand this concept? So mu1 upon CO plus mu2 upon CI1 is equal to mu2 minus mu1 upon CC1. This is your equation number 1. Again, take the surface concave xp2y. x, p2 and y. So if you take the distance x, p to y, so you know this is the image, this is the object. Then you write here minus mu1 minus mu1 upon p2. Mean first of all you write the object I1 and then plus mu2 upon p2i is equal to mu2 minus mu1 upon p2c2 center of curvature. Again we write here according to this concept minus mu1 upon ci1 plus mu2 upon ci is equal to mu2 minus mu1 upon cc2. This is your equation number second. Now adding 1 plus 2. So mu1 upon co plus mu2 upon ci1 plus minus mu1 upon ci1 plus mu2 upon ci is equal to right hand side mu2 minus mu1 common mu2 minus mu1 1 by cc1 plus 1 by cc2. So you know positive and negative this will be cancelled out mu1 upon co plus mu2 upon ci is equal to mu2 minus mu1 1 by cc1 plus 1 by cc2. Again you can apply sign convection. Again you can apply sign convection. So how to apply sign convection? CO, the direction of incident ray in this direction. So mu1 upon minus u plus mu2 upon ci mean plus b is equal to mu2 minus mu1 1 by cc1. Same direction of incident ray. So we take r1 plus 1 upon cc2. cc2 is the opposite direction of incident ray. That's why we write here minus 1 by r2. Again mu1 by mu1 upon minus u plus mu2. Can we write here the equation? Sorry, one more please. Here mu1, mu1, mu1. So mu1 divided by plus b is equal to mu2 by mu1 by mu1 1 by r1 minus 1 by r2. So this will be cancelled out. So minus 1 upon u plus 1 upon b is equal to mu minus 1 by r1 minus 1 by r2. This is your lens maker formula. So you know lens formula in grade 10 you read minus 1 upon u plus 1 upon b is equal to 1 upon f. So we write here 1 upon f is equal to mu minus 1 by r1 minus 1 by r2. One more concept is applied here. Mean how to find the power of a lens. So power is the reciprocal of focal length which is measured in meter. So just you understand if the examiner here in the exam the question is find the first principal focal length and second principal focal length of the mirror. So like this is your convex principal axis. This is your object, and image is formed at infinity. Here you write f1. So it's your optical center, and this is your object u. You can write here. This is your object. So using the last formula minus 1 by u. So here you can write here at the place of, yeah, you write here f1. So 1 minus 1 by u. So incident ray are traveling in this direction, and you can calculate the distance in the opposite direction. So minus 1 upon minus f1. So plus 1 upon b. B is equal to infinity. 1 upon infinity is equal to mu minus 1, 1 by r1 minus 1 by r2. So minus minus cancel out. So first focal length is equal to mu minus 1, 1 by r1 minus 1 by r2. If they told for the second principal focal length, so again we draw the convex. These are the two incident rays traveling from infinity, mean object is placed at infinity, and they are converged at the principal focus C, and this is your f2. So again you can put the value minus 1 upon infinity object in this formula. So B is equal to plus 1 by f2 is equal to mu minus 1, 1 by r1 minus 1 by r2. So again the second principal focal length is minus 1 by r1 minus 1 by r2. And this can be right here p power is equal to mu minus 1, 1 by r1 minus 1 by r2. You know, power is the reciprocal of focal length, which is measured in meter, and the unit of power is diopter. So this is your lens maker formula, and we solve some numerical on the this equation. So how to solve? Suppose a biconvex lens with two faces of a same radius of curvature is manufactured from a glass of refractive index is 1.55. 1.55. What should be the radius of curvature for the focal length of the lens is 20 centimeter. Why convex lens? Mean there are two things are given. There are two things are given. First one, a refractive index, and second one is the focal length. So how to solve? Why convex lens? It means the refractive index mu is equal to 1.55 is given, and second one the focal length f is equal to 20 centimeter by convex lens. So you again apply R1. R1 is equal to plus R, and R2 is equal to minus R because it is in the opposite direction of incident ray. So again you apply directly 1 by F is equal to mu minus 1, 1 by R1 minus 1 by R2. So 1 by F focal length is given, that is 1 by 20. 1 by 20 is equal to 1.55 minus 1, and here 1 by R minus minus plus 1 by R. So from that equation, you will get here that is equal to 0.55. Am right? 1.55 minus 1 means 0.55, and it is equal to 2 by r. And you solve r. R is equal to radius of curvature. That is equal to 2 multiplied by 20 is equal to 40. 40 multiplied by 0.55. Clear? So after solving, you will get 22.0 centimeter radius of curvature. Clear? One more numerical from that concept. So just wait. Okay. The question is given. Listen again. The question is given. A small air bubble. A small air bubble within a glass sphere of radius 0.02 meter appear to be 0.01 meter. So you can find the 0.01 meter below the surface. When we look along the diameter containing the bubbles, find the real depth of the bubble along the line of the site. Refractive index mu is equal to 1.54 is given. So first of all, you will draw the diagram of the air bubble. Listen, it's a air bubble. You can see from this side, I clear. So this is your object. This is your object, and incident ray. So image is formed here, I, and this one is the center of curvature, C. So it's your pole P I, and this is your object U, and the distance of object and center of curvature, this is given 2 centimeter, and radius is given, that is 5 centimeter. Again repeat the question. Again, a small air bubble with a glass sphere of radius 0.02 meter. 0.02 meter. R is equal to 0.02 meter negative, because object lie in a denser medium, so it is in the opposite. Incident ray traveling in this direction, we can calculate the distance in the opposite direction. That's why R is negative. A refractive index mu is given 1.54. Refractive index, and the image B is given 0.01 meter. So image is also in this side, so that is also taken as negative according to sign convention. So you read the formula like this: convex spherical surface and concave spherical surface, like this. Image is formed, so the resultant remains same. So what is the formula? Minus mu upon b. There is a little bit change. If object line, listen one thing. 1 upon minus u plus mu upon b is equal to mu minus 1 upon r. This formula for when the object lie in a rare medium and image is a real, virtual, something else. If object lie in a denser medium, all the answer are same. If object lie in a rare medium while the image is a real, virtual, etc., the resultant remains same. But there is a little bit change. One more change is also here. Mu 2 by mu 1 is equal to sine I by sine R. What object lie in a denser medium, then you write mu 1 by mu 2 is equal to sine I upon sine R. So what are the change in the formula? The change in the formula is minus mu upon u plus 1 upon b is equal to mu minus 1 upon r. Yeah, 1 minus mu upon r. You can write here. 1 minus mu upon r. This is the formula. If the object lie in denser medium. So here is the air bubble whose refractive index is mu. So question is this. So you apply the formula mu upon u plus 1 upon b is equal to 1 minus mu upon r. Directly you can apply the formula. So here minus 1.54 divided by u, you will find out because the distance is not given, o and c is given, radius is also given, mean radius of curvature, and image is 1 upon minus 0.01 is equal to 1 minus 1.54 divided by radius of curvature is given minus 0.02. So how to solve this? 1.54 divided by u is equal to 1 minus, and this one equal to minus 27 and minus 100 is equal to minus 127. It means u is equal to minus 1.54 upon 127. So that will be equal to, object is always a negative, according to sign convection, 0.012, 0.012 approximately, 0.012 meter. So this distance from the pole is 0.012 is given. So this is the concept. So after that, so one student told me for the simple microscope and compound microscope, in the next class we will discuss about simple microscope uh, and compound microscope. There are two topic and we perform the numerical on the simple microscope and compound microscope. Thank you.